Hello and welcome to Bosch Professional Live UK. I'm Chris.
And I'm Danny.
And I'm Lizzie. Make sure to leave all your questions below and I'll get that over to Chris and Dan during the stream.
So, I'm pretty sure most of the audience out there are already fully aware what this is all about.
Yeah.
Today, Danny, what are we going to be talking about?
Right, we're looking at our entire range of 12 volt, 18 volt batteries and chargers. So quite a lot to cover today.
Quite a lot, yeah. I mean, we're going to be covering not only the original cool pack lithium-ion battery sets that we used to have, but we're going to be talking about our ProCore 18 volt range as well.
Yeah.
Now, we've talked about batteries and our lithium-ion, our cordless technology many times throughout all the live streams. Gosh, we've been going back at least now a year and a bit. We also talked about our battery technology when we had our 18 volt system special, that 2.5 hour epic live stream. And we had a little section there where we talked about our battery technology as well. But we thought we'll take today's live stream as an opportunity to go into a little bit more detail and give you guys the opportunity to ask questions as we go through it.
We'll try not to nerd out too much, but there is a little bit of technical stuff to go through.
So,
but there's plenty to learn here.
You just got the point there exactly. We don't want to bore you with the tech, but we are very nerdy people. And obviously our batteries, we like to say our batteries are really good, really high tech. And in order to explain that high tech feature, the cutting edge features that we've got on our battery, we kind of have to start with the fundamentals, right?
Yes.
So let's start off with the most basic thing of how a power tool battery works and how our lithium-ion batteries are, well, basically set up. The first thing we want to start off with is an 18650 cell, right, Dan?
Yep, widely available out there. Many people use. Anyone who vapes out there, I'm sure, is fully aware of what an 18650 cell are. Widely available, used in many different applications.
So if we cut to the close-up camera, you'll see there's nothing really special to see here. It's, I think the name of the actual cell itself is 18 by 65 millimeters. Yeah, that's how you get the naming structure. Now, we obviously purchase a lot of our cells from reputable manufacturers. We're talking about manufacturers such as Samsung, Sony, or otherwise known as Sanyo, Panasonic, and in the past we used to purchase cells from LG. So really reputable brands. Obviously, only the best go into our battery cells. Now, one of the points we want to say here is, right, Dan, that these cells are 3.6 volts, yeah?
3.6 volts is standard, and all the cells that we'll be talking about today are 3.6. So that goes from our standard cool pack batteries all the way up to our ProCore ones. But there are a few fundamental changes with the ProCore batteries, which we'll cover off later. Right,
so I've got an example of a compact 18 volt battery, and you can see here, if I just put that on the close-up camera, you'll see that there are 5 of these 18650 cells wired in series.
Exactly, and so what that does is that multiplies the 3.6 by the 5 cells that you're added. That gives you your 18 volts.
Now this is a compact battery. This is the equivalent of a 2 amp hour battery. So I think I've got the casing for one here. So you can see here with the side casing, right, so you've got your 2 values, you've got your voltage and you've got your amp hour. To those who aren't familiar, obviously the voltage is essentially, you could say that's the power of the battery, and obviously that powers an 18 volt motor. Now when it comes to amp hour, those who are familiar will know that's basically your runtime, your battery capacity, how much energy is stored in that particular battery pack. Now, this is a compact battery, so a single layer. However, typically speaking, most of you guys will be familiar with a double stack battery. So I'll put that next to it there. This will be your typical 18 volt double stack battery, cool pack battery that we've had for many years. And that could be, for example, if this cell was a 2 amp hour cell, then this would be a 4 amp hour cool pack battery.
These are wired 5 in parallel. 5 in series and then 2 in parallel. So that doubles the amp hour, but it remains an 18 volt battery.
Essentially what you've done here, if you want to use a simple analogy, this is a fuel tank and you've essentially doubled the layer of the fuel tank from a compact, another layer, so it's twice as much capacity. So now you're up to a 4 amp. So as you probably, again, I'm going to be probably patronizing a lot of people here, so you already know that more amp hour means more holes drilled, more meters cut, etc., etc. Many people do sometimes misunderstand or confuse amp hour as power, but no, it's purely a factor of runtime. It's important to know that. So as you go up in the amp hours from, say, 3, 4, 5, 6, for example, you're getting more and more runtime, you're getting more and more trigger time, and you're getting more work done per charge. Now, Important to know, let me pop this one back on here again. So this is again a equivalent of, let's grab that one here. This is the equivalent of one of these. So let's say that's a 4 amp hour battery. Danny, the module on top. Now we've talked about this many times. How should we explain this?
Well, this is classed as the ECP module. So this is the electronic cell protection, for short there. What this does is it monitors the internal temperature and the charge rate of the actual battery when you actually got it on charge. So it monitors the temperature and it can throttle back the charge rate dependent on the heat created from the energy transfer that you get from a battery plugged into a charger. Again, if you're transmitting any sort of energy from one place to another, heat is always going to be produced as a byproduct. And I think we all know from previous history that lithium-ion doesn't particularly go well with heat. So no. You want to keep that heat down to a minimum amount. Obviously, there's a comfortable little pocket of temperature that these work perfectly in. So yeah, that's exactly what that does. That also corresponds with a module that sits in the chargers as well, just to maintain the correct the voltage rate for you to prevent overheating of the battery. And that goes through the machines as well. They have a counter module that they talk to each other when it's plugged in.
It's important because obviously batteries, although we do say a battery is a consumable, but it's a consumable that you want to have for a long time. It's quite an investment as well. You don't want the batteries to prematurely die of temperature-related problems. Now, ECP, electronic cell protection, excellent. We say it gives the battery up to 4 times longer lifetime. Not runtime, although there is an effect on runtime. It does help, because keeping your battery cool generally will help with runtime. But when it comes to lifetime, so how long the battery will last for its entire working range, up to 4 times longer.
It's a protection on the investment that you've made in the batteries, because obviously if you've got more machines that use the same batteries, then you can buy the naked machines and use the batteries you already have. So again, you want to look after those batteries because it's a fundamental part of the kit that you have.
Absolutely. Now, so that's a active heat management solution, but ever since the beginning when we came out with our original, I think it was a 3 amp hour cool pack battery, we had a solution, we had the cool pack system. Now the cool pack system, here's an example, it's this red housing around it. I've got one here where the housing is already, the rest of the battery taken away, and you can see what we call the HDPE, or high density polyurethane, or ethylene.
Yeah. It's a running joke that you always get
it wrong, it's one or the other. Which is basically a thermally conductive polymer, right? So basically it's a plastic. Now normally you would say that plastics are a thermal insulator, but there's a spectrum across where you've obviously got plastics that obviously are more thermally conductive and those that aren't. And HDPE is up there with a plastic that helps conduct heat better than other plastics.
Yeah, it draws the heat away from those cells, maintaining the temperature or helping to maintain the temperature.
Now, so this is, I think this is quite unique in the market. I don't believe anyone else has really attempted to do this. This is really important, the way we manage our batteries, both the heat and also that leads to a better lifetime. As you can see, if I go to, let's go to the overhead camera very quickly. You can see here's an example of one of the 8650 cells in, and you can see here comes another one, sits next to it. And what you're doing there is when the battery and the cells inside are charging or discharging, then the heat will conduct straight into this HDPE material, and then it will transmit out into the environment. Yeah. That's good. You want the heat out of the actual battery and out into the air.
Those of you out there who've used a battery, especially on a grinder or something that's a really energy intensive operation for a battery powered tool, will probably notice that the battery will get warm. That's a good thing.
That's right.
We don't want ideally for it to be cold to the touch, because the chances are it's going to be cooking in there. I mean, at the end of the day, this is physics. It can't really be negated in any way. So heat will be generated. So a warm battery, in our case, is a good thing.
Yeah, exactly. We've had many people say, my other brand is fine. The Bosch gets really hot. Trust me, as Danny said, the physics is there. They're both getting hot. If you can't feel it, that's not necessarily a good thing.
It's not good for it, yeah.
So, yes, so in conjunction with the cool pack system and the ECP module means that we like to say we have a pretty good battery. The batteries themselves are made out of a glass reinforced fibre as well, so they are particularly robust feeling as well. So these are designed for the rigours of the job site.
Yeah.
Not saying you should be using these as hammers, for example, but we know what you guys do out there. But it can take quite a lot of beating out there on the job site, which is good because, again, the last thing you want to do is damaging one of those cells inside, because regardless of who manufactures the cells, if you damage them, then you run the risk of having something unfortunate happen.
You bear in mind this is fitted to a heavy-duty machine which is used, well, constantly, all day and every day. Even the rigours of just handling it, putting it down, picking it up, putting it down, there will be a certain amount of impact or damage that occurs to the outside of the machine itself anyway. So it makes perfect sense for us to make the batteries out of a material that can withstand that.
Absolutely. So we've got some questions, Lizzie.
We've had a few questions come in so far. We've got one from PF Cutters asking if there's any plans to try lithium phosphate in the future.
Not currently. We're still using the lithium cobalt solution. That's still very common within the market. The 18650 that we're describing now with we'll call it just the cool pack system, as well as you'll see later with the ProCore batteries, they are still using that lithium cobalt system. Lithium phosphate, now I'm not very familiar with what the pros and cons of that are. Perhaps in the future we may go to that, but I think we'll see how it goes. Yeah,
I think you'll probably find it's more than likely down to the rigours of mining and the stigmatism there is with mining lithium and cobalt, especially at the moment. If there's a change and the technology moves forward and lithium phosphate becomes more available or more widely used, I'm sure that's something that we'll embrace.
There's probably an entire risk assessment based on that technology. Now, I'm not familiar how it comes packaged, whether it comes in the cell-shaped batteries or whether or not it comes in a poly bag or something like that. It does entirely depend on what format these other batteries can come, these cells, what format can come in.
And then obviously with some different forms, there's obviously heat management issues there as well. So there's a lot to think about. There's an awful lot of development and design, intelligent design that's gone into these particular cells. And using them in our batteries. So again, it's going to be a slow process, I should imagine, if we do switch.
Yeah, I mean, we've got a really large department. We've obviously got an entire division that focuses on our battery technologies, not just for power tools as well, because obviously you know that Bosch is a very large company, and we're very happily say we're very much cutting edge when it comes to battery tech, even to things just like the e-bikes and things like that. So we know what we're doing. Oh, even the Bosch, automotive, loads of battery tech within the company. So I'm sure they're looking at it.
Another one's just come in from PF Cutters asking how the heat extraction compares with the new batteries and our old batteries.
Hold your horses, PF. We'll be getting to our ProCore 18-volt battery system and showing where we've made improvements and why.
We're just scratching the surface of the thing at the moment.
A little history lesson so we can work up to ProCore.
And then just one more for now, asking if the bi-turbo battery produces more power than the power stack pouch batteries as competitors.
Yeah, I mean, when we get to the ProCore section, we'll talk a bit about, we can take some more questions when we get to talk about competitors. ProCore is our solution to getting a cordless system working to the same power or performance as a corded system. And there are lots of different ways you can get to that. ProCore 18 volts, our solution. The DeWalt power stack system is a different way of doing something similar. And there are some pros and cons, and we can have a discussion about that, but we'll do that when we get to the ProCore section. Because that's the nearest, well, not necessarily the nearest equivalent, but let's talk about competitors towards the end, maybe.
That's the yardstick that we're working towards at the moment.
Exactly. Okay, so let's keep moving on. So we've discussed basically how a lithium-ion battery, or any battery, is formed, individual cells making up a battery. We've talked about our existing cool pack battery system. And we started off with this example here of a 4 amp hour battery, but over the years we've increased the capacity of these batteries.
If I put a 6 amp hour next to the 4 amp hour there, you can see that they're both basically the same size. So there's no physical difference in the actual size of the battery, yet we've managed to get more storage or more energy storage into that.
Chuck the 5 in as well and you'll see. If we had a 3 amp hour, you'd see that they're all exactly the same size. So the battery cell manufacturers haven't changed the size of the 18650 cell, because that'd be very inconvenient for us as a manufacturer. I know that some other, say, other manufacturers, other competitors may have had to change the size of their battery for whatever reason, but we've never changed. We've always kept it the same format because that's, quite honestly, I think that's the smart thing to do.
Yeah.
Got the consistency in the size, and then the weight themselves, then they all stay roughly the same weight.
They're all the same weight, yeah.
So all you're getting really is just more capacity, more runtime, more trigger time for no real loss. Obviously you have to pay for it, but
Yeah.
you're not paying for it in weight.
So that basically shows a clear evolution of those capacity of those 18650 cells.
Okay, so we've talked about the 18 volt battery, so I'll slide that over to you.
Yep.
So if I was face to face with you guys, I'd ask, what's this for? Let's get that close up camera. This is clearly from a 12 volt battery, or should I say, more originally, it used to be a 10.8 volt battery.
Yes.
Because 3.6 times 3 is going to be 10.8, not 12. So we've obviously got a wide range of 12 volt products and 12 volt batteries to power those machines, right, Dan?
Yes, we do. We basically the reason for the name change for these, we initially had the 10.8 batteries. There was demand in the market out there. We'll not mention any names from the specific manufacturer, but there's two ways of measuring the voltage from these particular cells. So you fully charge that 10.8 volt battery all the way up to 100%. And then you pop a multimeter on there, and for the float voltage or the max voltage,
peak voltage,
the peak voltage that you'll see will be 12 volts. However, when you're using the battery in use, it's 10.8. It says that's your float voltage.
That's right.
That's
yes.
your nominal voltage. However, like I said, other manufacturers out there decided to quote the peak voltage, and obviously that kind of led to a bit of an unfair advantage in the market. So unfortunately we towed the line there and changed our labelling for our batteries up to 12 volt. Now these batteries are fundamentally exactly the same inside. So there's no difference internally between a 10.8 volt battery or the 12 volt labelled batteries. They're exactly the same.
There we go.
Yeah.
So all we've done is we've just changed the sticker on the bottom. You can see here 12 volt, 3 amp hour battery.
Yeah.
Now,
So anyone out there with a 10.8 machine that they've had for quite some time, and they do last for a very long time, they can fit a 12 volt battery and vice versa. If they have a 12 volt machine and an old 10.8 battery, they're all fully interchangeable.
that's right. And when it comes to compatibility, again, like all of our batteries and our products, the 12 volt is the same way. We've got the complete backwards compatibility with all our machines and batteries, vice versa, since 2005, including the ones that are obviously labelled as 10.8 products and batteries.
But if you want extra runtime over and above the maximum of 3 amp hours that you'll get out of one of the single batteries, we do have here, same as with the other batteries, we have a double stack battery. So this has the 3 cells in the top here. And also, if you look on the underside there, you can see there's 3 cells in the bottom. Ah, there you go. You can see that exactly where they sit in here. So 6 cells in total, 3 series.
It's a double stack battery.
Exactly.
It's a double stack 12 volt battery. Now we've got 4 amp hour and 6. I think you mentioned that already.
Yeah, so they basically double stack with 2 amp hour cells or double stack with 3 amp hour cells. That gives you the 6.
And we quite like using the double stack batteries in the workshop because you're using a 10.8 product, most of them will stand up quite nicely because of the base.
That's it. If you're doing a lot of bench work, there you go, pop that straight on down. It sits nicely.
Now, while we were covering the whole point of 10.8 and 12, we obviously had some of the questions earlier talking about competitors. It's important to note that some of the other voltages out there can get a little bit confusing, such as you might have things like 20 volt and you might have 40 volt. Essentially, that's working off the same peak voltage theory that we had here from 10.8 to 12. So we often get many people asking us about the 20 volt system and the 40 volt system. And essentially, I'm not here to poo-poo any of our competitors, but essentially you're looking at 20 volt really being 18 and 40 is just 36 volt with a different label, to be honest.
That's it.
So we're not going to spend too much time dwelling on that, but that might help some of, if you're going to ask us some questions about those other systems and whether or not they're better or worse, they're just the same voltages really, it's just a different sticker.
Yeah.
Okay, so 12 volt, we've got a couple of batteries, we'll bring up examples here. So we've talked about the smaller and the larger. We've obviously got a range of the single stick batteries. I think in the past we had 1.5 amp hour, we had 2, and now I think it's 3 is now
three's the maximum.
3 is the max on a single layer.
Yeah. When we talk about the evolution of the cells earlier, obviously went up to 3 amp hour being the maximum amount of power we can get out of a single 18650 cell. Hence, the maximum of the cool pack batteries being 6 amp hours, which is a double stack of the 3.
Yes, I was just going to say that's what we've got here. With the double stack, you've got a 4 and a 6.
Yeah.
So that's our entire range of 12-volt batteries.
Although there are other more spacious, should I say, batteries out there that you can buy an 18650 cell that goes up to, I think it's 3.5 amp hour. We decided to draw the line at 3, mainly because these are used in a working environment. So there's the rigours of being handled roughly. Going a higher capacity on a single cell could cause potential issues when it comes to reliability.
Exactly. So let's go and have a look at some of the 18-volt batteries. Let's start off with one of our compact batteries, probably the most common one out there. This is it.
Yep.
So what we've got here is an 18-volt, single-layer, 2 amp hour cell, a compact battery, we like to call it. It's fine. It's lightweight. It only weighs 0.35 kilograms, so nothing at all. It's you won't even feel it on the tool.
No, that's it.
And these run. I think we do a 3 amp as well as this, I believe.
I think we do. We don't actually have one here, but yeah, that would be using the 3 amp hour cells.
Yeah, I think we had 2, 2.5, and 3 amp hour, and we've got an example of quite an old one actually. We don't run this one anymore, but we had also used to have the really old 1.5 amp hour.
I don't think that even benefits from the cool pack system.
Don't think it even needed it at that amp hour. So 2 amp hour is pretty much the standard compact battery that you might see in some of our smaller or more cost-effective combi kits. But really, when we talk about battery power, we're really talking about our dual-layer standard cool pack battery. So we showed them already earlier, but we've got 4s, 5s, and 6s.
6s. Yeah,
right.
we've got them all there.
They basically weigh about the same. They're all about 600 grams, isn't it?
Yeah, it's about 600 grams.
Regardless of, I think it's about just over 600 grams. Regardless of the amp hour or their storage, they're all about the same anyway, and they're all the same size too, which has been beneficial going through the years. I think we used to have, 4 amp hour used to be the standard you'd get when you bought a full kit with batteries and chargers. My understanding now is that 5 amp hour is pretty much the standard, and if you want, you can purchase a 6 amp hour in addition to complement your range if you want a bit more runtime. Well, okay. Questions? Perfect.
There was a question on the 2 amp hour battery. Fina likes the low weight of it, and some of the smaller 18-volt tools aren't much heavier than their 12 counterparts with it. Will you continue to make it indefinitely, or will it be upgraded, keeping the low weight?
I think they're going to. I think the limit. We can talk. I think we could go into depth, but we're not going to in this particular presentation. But the capacity of the 18650 cells, this technology, topped out at 3 amp hours. I think there was a 4 amp hour, but as Danny said, we didn't want to go with it because the thinner or the more tightly you wrap these cells, they get more and more prone to, they're thinner. So we don't want them to potentially get damaged. So we limited ourselves to the 3 amp hour to give us that safety factor, because these are batteries that are used in quite rugged, they need to be rugged, and they're used in quite, I don't know what to describe it, harsh environments. So I doubt we're going to make anything more than a 3 amp hour compact battery. However,
think of the internal structure of that cell as a roll of carpet, if you will. So there's a positive and there's a negative, an anode and a cathode. In between those two, you have a separator membrane. Obviously, if you roll it tighter and tighter and thinner as technology has moved on, you're making that separator thinner. So obviously, if you get to a point where it's incredibly thin, then you're losing the robustness of the cell. The potential for a short is far greatly increased. That's why we stopped at 3, mainly to prevent any sort of thermal runaway from an industrial environment.
When we get to our ProCore section, which is just going to follow these questions, you'll see that there is a interim between our compact batteries and our new technology compact battery, which is a little bit heavier, but it still might fit that need as a compact, high-energy battery.
I don't think there's a great difference in it, actually, to be fair. It's pretty close. So,
yeah.
Just one more for now from earlier from Fina as well. The cell wiring looks like it's connected directly to the terminals. Does this mean that the battery requires communication with the tool to protect itself and shut down power output?
Well, you're kind of describing the ECP. Maybe you're describing the ECP module again.
Module.
For those who may have joined a little later, we'll jump onto the overhead camera quickly. we might be talking about our ECP module. So we had this pretty much from the beginning when we first came out with it.
Yeah, the cells are basically connected through the module at the top here. There's also a fuse here as well. So in the case of catastrophic failure of the cells or a short, that will cut the power completely. So there's fail-safes built into this for that exact reason.
Yeah. Okay, so good. Oh, we're enjoying it. Good questions. So, because I said we knew we needed to have a dedicated session talking about battery tech because we can get really into the weeds, but it's really important how to understand our brand, and most importantly, as everyone, well, including ourselves, are really pushing cordless technology for obvious reasons, showing how our batteries, showing how our batteries are designed and how they're deliberately designed to a really high-end, cutting-edge level.
This is a defining factor of your purchase of power tools at the end of the day, and showing you that our batteries are incredibly robust, incredibly well built, with a lot of innovative design features designed to protect your investment, as we said already.
Right. Done with the questions, Lizzie? Okay, so we've talked about our standard 18-volt battery platform. Great, ideal. These have been really good at powering all our normal hand tools.
Yep.
You know, our normal circular saws, combis, drills, all those kinds of things. Now, obviously, people have got very used to the 18-volt platform, and people have been asking, I want more power. I would like to have the ability to run a bigger machine, such as a miter saw, table saw, even a really large SDS hammer, but I still want to have the freedom of a cordless system, particularly, well, in our case, we said particularly in something like 18 volt.
Yes.
Now, there are many options out there in the market. Some have gone up to 36 volt or 40 volt, and some others may have even gone all the way up to something like 54 volt with a very novel solution. However, we wanted to stay with 18 volt, and we'll explain why that's a benefit to you as a user. Now, with the 18650 cell, okay, there's a limit to how much power could be generated by a battery powered by an 18650 cell. Let's just say, for example, well, I should say, whenever we've been talking about batteries up to now, we've been talking about voltage and amp hours. Now we need to talk about a third factor that's very rarely talked about, which is current, which is amps. Okay, so one of these kinds of batteries will give you approximately 45 amps of power.
Yeah, that's 22.5 amps of power per single layer. So a single layer, 22.5.
Okay, so if you're looking at any brand of power tool battery, which is 18 volt, you'll be looking at roughly the same amount of amps or current per battery. So everyone's getting around 45 amps out of a double layer, particularly to a double layer battery. Okay, but if you want to run a more powerful or a bigger machine, right, you're going to need more power. Some might use voltage to get that. However, we wanted to do something slightly more novel. Instead of going with more 18650 cells, we decided to change it up to a 21700 cell, right, Dan?
Yeah, again, so exactly the same physical structure as the 18650 cell, except 21 millimeters across by 70 millimeters in height. So this is 21700, it's called. Yep, exactly the same physical structure. However, this has a starting capacity of 4 amps. So this is already 1 amp hour higher than the 3 amp hour maximum that we put out before.
Now, moving up to this cell, I think if you haven't said this, I do apologise. Moving up to this cell means we can draw double the current, double the amps. So remember, on a double layer, we're talking about 45 amps. Well, with a 21700 cell, we can theoretically pull up to 90 amps of power. That's the kind of thing we need to run a bigger tool, but only using 18 volts. Now, whenever we have our training sessions and we're talking about the 21700 cell, we always ask the question, well, if you're going to draw double the current out of this cell, what's going to be the drawback?
Well, the drawback quite clearly is going to be heat. The one kryptonite, if you will, for our lithium-ion batteries and all lithium-ion technology.
So we already knew that. Look, we're an electronics company. We know what we're doing. We know that if we're going to draw double the amps, we have to mitigate for that additional heat. Otherwise, you're just going to end up with batteries that are throttling back due to ECP, which is good, but bad if it's always doing it. Or worse comes to worse, you might be killing these batteries. We don't want that. We want to make sure we're bringing out a proper product. So we redesigned our battery from scratch, essentially.
Well, so redesign, we really stepped up to the game here when it comes to temperature management or heat management for these particular cells. There's loads of intelligent design features that we've built into these new ProCore batteries that will mitigate that heat issue and obviously it works a treat. It really does.
All right, so if I cut to the close-up camera for a second. So here's an example of a ProCore 8 amp hour battery. Obviously, as Danny said, it's got 2 layers of 4 amp hour batteries to give it the 8 amp hours. Now, if I flip it around, you can see a number of things. Obviously, if I tilt that forward, you'll see clearly it's going to have its own form of ECP module as standard. So you've got that transitioning from the original battery platform.
Fully silicon sealed as well, obviously silicon being very, very tolerant of high temperatures. So.
Yes. On the side, you can see here that the actual cell connectors are a different material. Now these are we've upgraded. It's a good upgrade from copper as opposed to the old nickel plated. Yes. So copper, why copper? It's a far more premium material. It's a material that handles both the
temperature and the internal resistance is also incredibly low as well. So you're not causing any issues with hot spotting by narrowing connections. So again, it can handle that heat a lot better.
The actual cool pack, so the HDPE material that surrounds the cells themselves, has been upgraded. So I'll push that to one side and I'll cut to, let's go to the overhead camera, and you'll see here that each individual 21700 cell is individually enclosed in its own little pocket of HDPE material. That means that all the heat, well, the 360 degrees around it, the heat is being pulled out of the cell into the environment, which is great. If you compare that to the previous generation of 217 of Coolpack 1, using the 18650 cell, you can see that the cells used to sit next to each other. That was fine for this technology, but because we're trying to draw even more power out of these cells, we wanted to optimize that to make it the best possible.
You really don't want those air gaps in there.
Yes.
In fact, during the manufacturing procedure here, when these are still warm, straight out of the manufacturing process, they pop the cells in then, so when it constricts around the cell, it eliminates any air gaps at all. It's basically interference fit in there.
And lastly, well, I say lastly, but there's a few other points. I'll see if we can get that on camera too. But we've also got a TPE, which is basically just a rubberized rubber.
Thermoplastic elastomer.
Thermoplastic elastomer, exactly. So it's a soft rubber that basically forms a seal around the outside of the battery here, in contact with the connectors on the side, which also helps conduct the heat being generated by the contacts out of the sides of the batteries to help reduce the temperature, keep the batteries cool. So in conjunction with the standard Coolpack version 2 and the side plates and the ECP module, upgraded ECP module, that's how we control and regulate those higher temperatures that this battery would typically be able to generate. It's important to notice, actually, I should point at the side here, from close-up camera, you see that we've also improved the sturdiness of the batteries by adding these metal corner reinforcements. The batteries themselves are not much heavier, but they are a little bit more solid. And you can really feel that if you ever pick up a ProCore battery, but these really help. If they're going to fall on the edges, then that limits the amount of potential damage to the battery.
Yeah, these weigh around about 1 kilo for one of the double stacks, the 5.5 amp hour or the 8 amp hour. So a little bit of weight there. Obviously, if you drop a machine with the battery on it, the chances are it's going to be the battery that hits the floor first because of the weight. So yeah, it makes sense to have those metal reinforcing sections in the corners to prevent any damage to those cells. Remember, we're trying to keep those cells nice and cozy in there and protected from any sort of impact.
That's right. And again, just like the previous battery technology of our Coolpack, these are GF60, so glass reinforced fiber, so a really solid, sturdy battery. It's like a brick. There's nothing
There's
moving.
barely any air in there.
There's no air in there,
solid.
and nothing moves. It's like a solid brick of a battery, which is good because you want something, as Danny says, no air gaps, no play, but also sturdy enough to handle the rigors of the job site.
That's it. So
I'll be honest, we're really proud of our ProCore 18-volt battery system. So we've made a discussion. We've showed you how we've changed the cells to the 21700s. We've showed you how we've improved the internals for the ProCore battery to make the internals handle the heat better, also are generally more rugged compared to the previous Coolpack batteries. So let's have a look at the range of batteries that we've got. Should be pretty straightforward, to be honest. So I've got all the examples here. Let's start off with the 4 amp hour ProCore.
Yeah. When we spoke earlier about a single layer 2 amp hour and the potential for having a higher capacity battery, this one is really only it's only a fraction of a 0.1 of a kilo heavier than our are single layer, I think, or the double layer there. So there's barely anything in it. So this is a higher capacity solution for a compact battery.
Yeah, you can see there on that previous close-up shot. You can see that there's very little height difference. There's very little weight difference either. I think it's slightly lighter, about 500 grams as opposed to 600 and something. The advantage here is you're running a single layer. So there's your single layer of 21700 cells, but we don't skimp on the technology. So you've still got the copper connectors. You've still got the HDPE cool pack material and the ECP module, etc., etc.
Well, if you remember, the 2 amp hour single layer battery was kicking out 22.5 amps. This is the full 45 amps. So you're getting double the amount of power from the same amount of cells, just slightly bigger cells.
So essentially, for all intents and purposes, these two batteries, the Cool Pack 4 and the ProCore 4 amp hour, are just as powerful as each other. But with the ProCore running half the cells. Yeah,
and you might get some advantage as well because we're using those copper contacts. You're not going to get the hot spotting. The temperature management is obviously a lot better.
Now, important to note that the ProCore 4 amp hour battery, excellent battery, but we wouldn't recommend these for a bi-turbo machine. Not if you want to get the 100% performance out of a bi-turbo machine.
You really need those 90 amps for that. Obviously, as we said, this is only putting out 45, so you have to move up to a double stack of the 21700 cells.
That's right. So first up, I have the 5.5 amp hour, okay, and in addition, also got the 8 amp hour battery.
That's our 2 double stack offerings for our ProCore 18 volt range.
Now, these are the batteries I'll typically recommend for the majority of bi-turbo machines. Something like a impact driver, or wrench, sorry, I should say. The combis. Because any machine would be fine.
Bench top's perfect for this, but there is a better solution actually for bench tops. But yeah, they're perfect for this.
Yeah. If you need more amp hours, we've got a solution for that. But typically 5.5, 8 amp hour, coming in at just under a kilo.
Just under, yeah.
Perfect. The batteries themselves, you know, didn't even point out on the last one, we've got updated the actual battery indicator on the back here as well. So we've got, we only used to have 3 bars on the old batteries. We've added on some additional batteries there, so you can see battery indication marks.
20% per light. That's really easy to work out.
So 5.5, 8 amp hour, but if you really want extra runtime, not more power, just extra runtime, then we've got this bad boy. We've got the 12 amp hour ProCore battery.
Yes, so that contains 15 cells. That's a triple stack.
I think I got one that you did a cutaway on.
I have, yeah.
And again, just to prove the point that
you can see that exactly the same technology remains between the two there. We've still got the TPE material. We've still got the copper contacts, it is a solid brick.
It is an absolutely solid brick, but not too bad. About 1.35, 1.4 kilograms.
Yep.
You definitely feel it. It's definitely. I'm not gonna beat around the bush here.
Yeah.
It is a solid battery, but again, if you're going to be putting this on a tabletop machine, a miter saw, it's not a problem. And even on some of the products, it actually counterweights the machine quite well.
Yes.
Even on a very heavy, I say very heavy, moderately heavy machine like the GBH 18V-45C, which is the equivalent of an 8 kilo corded hammer, we've actually changed the battery position on some of these machines so it balances well. So this would sit up front.
You barely feel the weight because it's nicely positioned between your hands.
So there's some intelligent engineering going on there to counterweight the machine and the battery pack. But if you want the runtime, that's what you're going to have, 12 amp hour.
Yeah.
Now, so one good question that I'm sure we're going to get is, well, how can an 18 volt battery pack be as powerful as something more powerful? And we're going to have an example here of the fact that, yes, double the amps means a battery will drain essentially twice as fast. But we counteract that. Why? Because we start off with a battery, something like an 8 amp hour battery. Right, because we know that the battery is going to be, the higher current is going to drain a battery quicker, so we put more battery power in there, or more energy in there. And if you really, really are worried, then a 12 amp hour battery will compensate for that. And as you'll see towards the end of the presentation, it's not only the fact that we've got batteries that are higher amp hour to compensate for the higher ampage, but we've got some really powerful chargers. That means if you are depleting your batteries quickly, then these chargers will get you up and running really quickly.
That's it, yeah.
Okay, so we'll probably take some questions on that, because I'm sure you might be asking about runtime with a ProCore running a really big bi-turbo brushless machine.
Yeah.
So, any questions, Lizzie, or should we keep going?
There are a couple have come in actually, asking relating to the green range. As the market has changed since we separated the green and the blue, do we have any plans to combine the battery platforms?
Unfortunately not. It's a good question. The DIY range is not compatible with the Pro range. There's somewhat of a deliberate decision there, which is unfortunate because we do have, for example, we were going to just, in a minute, we're going to talk about our AmpShare alliance, which is talking about interchangeability of batteries. But DIY, the HG brand, also have their own 18-volt alliance. But again, it's not interchangeable with the Pro.
No.
The reason being that the home and garden machines are built to a different standard to our batteries, to our machines. So we wouldn't want people running a DIY home and garden battery on a professional power tool.
Yeah.
It wouldn't work. It wouldn't have enough power. It's not designed for it.
The lawn and garden, home and garden batteries do contain a form of ECP. They have an
Lithium-ion.
Lithium-ion, the electronic cell protection in a DIY machine. However, it's not as sophisticated as the professional range ones. The problem there is, obviously, you're asking someone who's going to be occasionally using a DIY machine to pay out for a battery that contains a lot more technology, and it is going to have a slightly higher price point.
Yeah.
So it will limit the DIY range if something like that was to happen. So I understand that currently we're keeping them separately, mainly because of that reason.
Yeah, just unfortunate, but as we've discussed, it's easier to keep those two separated. Yeah.
Then just one more question for now, asking if we process our own battery components.
Process, well, we have our own, all tools and batteries are all manufactured in Bosch-owned factories, if that answers your question. Obviously, we don't produce the lithium-ion cells ourselves.
No.
It would be inefficient. There are obviously specialist companies, as I said, like Samsung, Sanyo, Panasonic, and I think I said it, wasn't I?
Yeah.
And obviously they are the ones that manufacture the cells for us. They manufacture the cells for many people out there anyway. But
they're really good at what they do. It makes sense for us to use their products rather than actually create our own.
That's right. And obviously then they are brought to our own plants and they are assembled in a Bosch factory.
Yeah, the batteries are fully assembled, fully built by us. Yeah.
And in many cases with some of the previous ProCore batteries, we also had a patented laser welding system. I think that was our factories in Hungary, for example, that used to do that. But there are many factories, obviously, in Asia, because that's where all the manufacturing of lithium and the processing of lithium is done. So we've obviously had people in the past concerned about where things are manufactured, but again, reassure you all, it's all made in a Bosch factory as opposed to one that we lease out, for example.
From an ecological point of view, it makes perfect sense to put the batteries together where the raw materials are. But like Chris says, the factories are owned by us and they're staffed by us and they're monitored by us, and they're Bosch factories basically.
Okay, so we'll move on. We've got about a quarter of an hour left. We want to make sure we try and keep it to about an hour, but I think there's a run the risk of going on and on. It's important to talk about our AmpShare or partnership alliance when it comes to our 18-volt battery system. Now, we've been talking about this off and on for the last year or so. We've mentioned it a few times in many of our live streams. Have I got an example of one?
There must be one here.
Oh, there must be one somewhere. Oh, probably not. So what we've got our AmpShare alliance where, because we manufacture really good batteries, again, for all the reasons why we've discussed it earlier with you, because we manufacture a really good battery, and more important, because we're a global company, we've got the infrastructure all around the world to produce batteries for lots of different people, and in addition, because we've produced over 80 million batteries worldwide, what we did is we reached out to a number of other manufacturers. Some of them could be direct power tool manufacturer competitors, and said, we manufacture a really good battery with really great technology inside. Would you like us to be your battery provider and you have your tool modified to use our batteries? To be honest, that's a really great deal for them because they no longer have to worry about manufacturing and storing these batteries. And it's really good for you as a user as well, because that means if you were to buy let's say a Bosch machine with a Bosch battery, and then you went and bought something like a Fine Multimaster, because Fine is one of our AmpShare partners, then with selective products and more as we go on, then you could quite easily just grab your Bosch battery, put it on your Fine machine, and then you're way to go. You don't have to have a whole bunch of different proprietary batteries for every single one of your brands.
From an ecological point of view, that's really good, because you haven't got to have the same technology in lots of different batteries just sitting around the place. You can just use one battery over and over again for multiple things.
That's right.
So, great idea.
So you may recognise some of the brands, some of them you may not, but we're adding to these brands over as we go along. I mean, when we first launched AmpShare, I think it was probably about 20 or so brands had already jumped on board. That was probably about a couple of years ago. Now I think we're well over 20 something. We've got some big brands in there that you may recognise. Someone obviously Fine's a good example. Rothenberger, so Fine and Rothenberger, they're our premium partners. They're our founding members with us. We've also got other companies like Wagner that you might recognise, the paint sprayers. Gosh, there's so many Ramsets,
Lead
Lenser, Klauke. There's loads of really, some of them are quite niche, some of them aren't. I mean, Fisher have fixings, but they also have power tools. There's a really long list. Thank you, Lizzie. There's a really long list of partner out there, manufacturers making a lot of different products. Some are similar, because obviously Fine make a really good multi-tool. We obviously make one too. We made Starlock in conjunction with Fine, so there's a good long relationship
got a
with
history of partnership with them. So
exactly. So what the AmpShare allows is both people buying non-Bosch products and Bosch people buying Bosch products. Obviously, it really opens up the range of products that they can use now, all running on an 18-volt battery. So here's an example of, obviously, you see the ProCore labelling on there. So you'll notice that the newer batteries, the newer ProCore 18-volt batteries, not just the 8 amps, will have this new sticker on the side saying this is an AmpShare.
Not to say that, you'll also find those stickers on the original cool pack batteries as well. So obviously, if it's going to fit a ProCore battery, if the machine doesn't need the power of a ProCore battery, you can still use your batteries that you have historically from the 18-volt platform.
Yeah, I think we neglected to say it because it's so obvious. We forgot to say, obviously, ProCore 18-volt batteries are completely backwards compatible with the entire range of our products and the battery systems. All our machines, our bi-turbo machines, can take very old cool pack batteries, ProCore batteries, vice versa.
And this, like I said, that goes for the AmpShare partners as well. So we've really opened up the potential buying market there.
Yeah, so if you've got any 18-volt battery, lithium-ion, and you pick up a partner, pop that on, it'll work. They might have some products that are similar to bi-turbo, so you might be wanting to reach out for a ProCore battery to get maximum power, but again, it doesn't matter, they're all electronically compatible. So it's a really good win, not only for us and our partners, but for you, our users as well, giving you basically ultimate flexibility. And again, we're continuously adding partners to this AmpShare alliance. So
I would say, if you're curious about who's currently, because obviously they're adding partners to this whole platform all the time, just do a quick Google. I'm sure you'll find out exactly who's on the AmpShare platform. And
yeah, I think if you just Google AmpShare, I think it'll take you to the landing page that we've got, and it's obviously multi-brand. You can peruse that to your leisure. Okay, we've gone on about AmpShare too much, I think.
Yes.
But it's good. It's important to talk about. Okay, so we've got a little bit longer. We've got a little over 10 minutes left. I think we've really covered our battery technology, how it leads into our bi-turbo machines, why you need to run something like a ProCore 18-volt, either a 5.5, 8, or the 12 if you want to run the big machines to their maximum power. But you don't have to worry if you don't have them, because they are still compatible with your standard 18 volts.
That's it.
So when it comes to batteries, good, we've done that. What else are we going to talk about today? Obviously chargers.
Obviously, yeah. I mean, a battery is nothing without a charger, else you'd be buying an awful lot of batteries, basically. So we want to start off with the 12-volt range, I think. So here we have the GAL, which is the unit. You know how to pronounce the...
Well, do you remember G is for German for professional?
Yep.
Don't test me.
No, I don't. I can't remember.
And then obviously AL
is Acculada for charger. So GAL 12V, obviously 12-volt battery charger, and it's got the 40 after that. The 40 refers to the amperage of the charger itself. So this 40 is 4 amp charger. So this will charge a 4 amp battery in around about an hour, give or take the temperature management that you usually have with a charger. Yeah,
it's very simple, very compact. You see here one of the older 1.5 amp hour batteries. If you're going to use a standard battery, for example, say what we got here, like a 3 amp hour, for example, then you're going to be looking at about a charge time of about 80% within about 36 minutes. 36 minutes charging a 3 amp hour, or up to roughly about 50 minutes fully charge one of these batteries. So again, the whole point of having these fast chargers means if you've depleted one battery, you pop on charge. Hopefully you've got your backup, your secondary battery as a bare minimum. Carry on working. By the time you've done, by the time 36 minutes has gone past, this battery's already 80%, which is mostly charged. You can swap it over then, but to be honest, most of the times you'll find that it's going to be fully charged by the time you need your next application.
Yeah, I think when you're talking about the 12 volt range, if you've got like a small combi drill or a little impact driver or something like that, you're going to have a real job flattening that battery before you've charged another one. So you should always have power on tap.
Yeah. With a 4 or a 6 amp hour battery, on it, you can imagine that it will take a little longer. So we're looking at about 48 minutes to get up to 80% on a 4 amp hour, or 72 minutes to get 80%. And if you want them fully charged, then 4 amp hours, just over an hour. And then it's about 95 minutes to get a 6 amp hour battery fully charged. So pretty rapid at 4 amp hours.
It's not bad.
Okay, so that's we've only really now got the single charger for 12 volt. Let's have a look at some of the 18 volt charge we've got, because we've got quite a few.
Right, so this is the GAL here, which is very similar to the, well, other than it's an 18 volt version, this is the GAL 18V-40, so again a 4 amp charger. But yeah, this is kind of your base model 18 volt charger that will come in most of the kits out there. Plenty fast enough for the majority of applications. But say 4 amp hour, that's again charge a 4 amp hour battery, round about 65 minutes.
Exactly. And if you want to step up to something like a 5 amp hour or above, then obviously the time goes up a little bit, but like about, again, up to about 60 minutes for an 80% charge and a 5 amp. So you get the idea. It's a good charger to have, again, nice and compact, no frills, but it gets the job done. Let's move on to another charger. Let's have a look at one that we've pretty much,
it's still in the range.
Yeah, it was the good old reliable GAL 1880 CV.
So there you go. There's
this is the one most people are very familiar with. We've had it for many years.
This has been out there in the market for quite some time now. There's actually, when we were talking about cooling before, obviously this is an 8 amp charger, the GAL 1880 CV. This is this little section at the bottom here, that little red grill there. What that does is that when you popped your larger capacity batteries, or even some of the smaller capacity batteries, you see there's a grill at the front there, just in front of the terminals. Well, those two line up. What it does is it sucks air through the battery, through that cool pack system that we spoke about earlier, cools the battery, so it's got active cooling built into this particular charger. So again, you're not waiting for the temperature to drop before it will start charging. This actually draws the air through it and cools the battery, so it will charge quicker. Again, it allows you to put that 8 amp hours worth of energy straight into that battery, and it monitors and controls the temperature itself. So.
Worth dwelling on for a split second, which is obviously if you're using a tool very hard and you've got a high draw application, obviously the battery's getting warmer. Remember, the ECP module is potentially kicking in. So if the battery is really hot, especially if you completely drained it and you put it on the charger, don't be surprised if it won't automatically start charging straight away. These are smart batteries and smart chargers, protecting your investment. The charger will wait until the battery is sufficiently cool enough before it starts adding power. Because remember, charging and discharging generates heat. So you get a little warning indication down here, for example.
There'd be a red flashing light for that, just to let you know that it's over temperature. You'll hear the fan cutting, and it will start drawing air through that battery to cool it down.
Once it's safe to do so, then the charger will start charging. So nothing wrong. It's all as it should be. It's protecting your investment, protecting that battery, keeping it cool before it starts charging.
Another thing that's worth mentioning with these 18 volt chargers as well is we get asked every now and again, how do I know that it's at 80%? The charge light at the front here, the flash rate will change, so it's slightly different between flat all the way up to 80%, and then the charge rate changes and the light starts flashing at a different rate as well. So it tells you, you'll know if it's on the last sort of dregs of the charging there. So that last 20%, the flash rate changes.
Okay, last little bits of facts before we move on to the next product. Obviously, as an 8 amp hour charger, that means you'll be charging your standard 4 amp hour battery up to full in less than just around 35 minutes, or 80% within 25 minutes. If you've got a 5 amp hour or above, then you're looking at about 30 minutes to get to 80% and about 45 minutes up to full. So again, it's an excellent charger. There's still many of these out in the market. If you haven't got one, if you've only got one of the standard ones, worth grabbing a fast charger like this one, the 1880 CV. Okay, let's keep going because I want to get done by 5-ish.
Right,
5-ish.
so next one's a bit of an oddity. It's a GAX It's not a GAL, so it's a GAX charger.
It's a hybrid.
It's a hybrid because it has that X in the name. So what this one is we've actually covered off 4 amp hour chargers and 8 amp hour chargers. This is a 3 amp hour charger. So what this is, it sits nicely, well, sits at the bottom of the range for charging times. However, it quite capably charges a 12 volt and an 18 volt battery.
That's not the right pop-up. But anyway, we'll push past that. Yes, the GAX 18V-30. It's a sequential charger, the first one of 2 sequential chargers that we've got.
The last one you put on will be the one that charges.
That's right, so there you go. Give me a battery. So as you can imagine, you can just have those both on. Really good if you've got a system where many people ask us, why don't we have one? Well, we do actually have one, and this is the one here. So if you've got a 12 volt system and an 18 volt system, then the GAX 18V-30 should be your choice.
So you don't have to carry around 2 chargers basically.
Yeah.
Everything's on there.
It's even got a little on the front here.
Yep.
A little, I think it's 2.1 amp charging. USB charger on the front there, just as a nice little extra.
You charge your phone at the same time.
Right. Okay, so let's keep going because we've got 2 more chargers that we want to talk about. Next one I want to talk about is the multi-bay. I've got the example behind me.
Yep, you've got that one there.
Okay, we have talked about this in the past. Okay, actually this is one of the newer ones that's now got the AmpShare sticker on the front as well.
Is it?
But what we've got here is we've got our GAL, again, Aculada, 18V6-80. So it's a 6-bay, 8 amp hour charger. So essentially we've got 8 fast chargers stuck on in one system.
Yeah.
It's sequential, so which means you'd pop on your 6 batteries as you go around, and it will charge each one. Thank you.
Pop some more on that. There you go.
Okay, it will charge the batteries up to 80% sequentially, and then go back round and top them all up to their 100%.
Yeah. Remember, if there's one particular battery you want to charge up quicker than the others, there's a play button on each of the bays, so you can prioritise that battery if you want to.
Yeah. And you'll have the same thing as before. You've got your little warning symbol on the top that if the battery's too hot to charge, it will skip that one and it will move on to the first battery that is in the right condition to start charging. Be honest, we love these in the training centre because they work as a really good solution just to carry your batteries, because then you can carry 6 ProCore batteries, 6 whatever batteries you want on there all together, which is nice. Plug it into the plug it into the wall, and then they're all charging again. And in addition, it also has like a little L-box hook here as well. So if you want to hook this onto the edge of an L-box, cut the overhead for a second for us, Rob. See, there's these 2 little hooks here that allow you to hook it onto an L-box. So when you're trolleying or using one of the L-box caddies, for example, then
pop it over the edge.
Yes, exactly.
And there you go. It's, you haven't got you've got both hands free to push your caddy then.
Yeah. And remember, it's an 8 amp hour charger, so just like the GAL 1880 CV, you've got charge times of around half an hour for your standard 4 amp hour battery, etc., etc. Okay, so let's get to the piece de la resistance.
Yes, our fastest charger. We're already, with the ones that we've looked at now, we've topped out an 8 amp hour charger, but obviously we want to put energy in and out of these batteries, these ProCores especially, as fast as we can. Again, heat's generated, but the only way we're going to do that is with a higher amp hour battery charger. So we went whole hog with this. Instead of an 8 amp hour, we produced, actually I can't, let me unplug this for a second. Oh, there you go.
Yeah, so world's fastest charger, I believe.
World's fastest charger. You have.
I think we can still make that claim.
There you go. That's the GAL, so Aculada, same as the other ones. 18 volt, 160, and it's got a C on there as well, which we'll come to shortly.
Yeah, being a 16 amp hour charger means this is rapid when charging. Yeah. Even something as big as a 12 amp hour charger. You'll see that even it can charge a standard 8 amp hour in up to 80% in less, about half an hour, to be honest.
12 amp hour in under an hour, which is
fully
crazy.
charged.
Yeah,
fully
charged in under an hour.
We also have a little boost button on the front here. So what you can do, it's an interesting feature, which means basically you can hypercharge the battery, so you can charge them a bit quicker. It does make the battery a lot hotter, so you want to use this you don't want to use it all the time, but if you're desperate, you can press the boost feature and it will hypercharge that battery, so you can get an 8 amp hour charged up in as little as 26 minutes. So, you know, that's pretty impressive for any kind of battery, but if you're really desperate to get that power, you can pop that on there, press the boost button, and get one of your ProCore batteries charged up really quick. The boost button doesn't work with the normal CoolPack batteries. It only works on the 21700 cells. So if you've got a ProCore battery and a 160 charger, you can charge a bit quicker.
Yeah.
Okay, so it's a connected product. So
yes. Let me plug this back in again and then try to get it connected again.
Right, so you might say, why do you want connectivity? What's the point of having another charger? Well, there's a few features.
Well, a lot of sites now have a, almost like a lot of big sites definitely have a sort of a porta cabin on site whereby you all plug all the chargers in and people will go there with their batteries and charge them up. This makes perfect sense, this particular feature, on those sort of situations. So you can have a battery on charge halfway across the job site, potentially, and it will tell you basically through your phone when it's fully charged. So then you can know when to go back and pick it up.
Great. So
let me set this up.
While Danny's setting that up, what we're going to do is we're going to pop a battery on charge very quickly, and then we're going to go into the Toolbox app, which we've already connected this as one of our tools, and you can see the options that we've got available to us. It's quite an array, worth going through just so you'll be familiar, because I'm sure most people, even the people that own this charger, they probably haven't ventured very far into the menu system, but there's some really great options, not just this boost speed, but other things like when your battery is fully charged, you get your little notification on your phone telling you it's ready to go, but you can make some tweaks to the charging algorithm. I believe you can even do a storage charge.
Yes, I believe you can.
Right, so let's cut to Danny's iPad and let's have a look through it. So talk us through it.
So basically you can see on here, this is the charger. I'm connected to it on the left-hand side. It's actually still showing the battery and its memory of the last one that I had fitted. I'm going to pop an 8 amp hour ProCore on here and we'll see if it will register it.
Probably going to hear the fan kick up. There we go.
I've got to connect.
So while Dan's doing that, you can hear the fans kicking up with the GAL 18V-160C. That fan is blowing curtains of air down the side. Remember, we've got those TPE material down the side, helping radiate the heat, and this fan helps pull that heat away from the battery.
You can see on the screen there, it's actually, when we talked about the ECP module communicating with the battery and the charger, you can see here that's taking place and being displayed here. So we're looking at a standard ProCore battery, 18 volt, 8 amp hour, currently at 70% charge, and it's giving me a 22-minute charge cycle. So 22 minutes, I'm going to be back at 100% again.
Have a quick cup of tea.
That's it.
And then go and pick up your battery. Perfect.
Yep, there'll be a charge complete tone you can see on the bottom there that will send that to my mobile device through the Toolbox app. So the same app that you would use for your other connectivity features, and that will tell you that it's fully charged and you can go and collect your battery. Obviously after your cuppa.
Yeah. What else we got?
We've also got this option for storage charge, and we can also, if I use that slider there, I can put it onto the power boost mode remotely using the app as well. There you go. That's 80% charged. There you go. Nice. So it's tapped out at 80%. Perfect.
Yep. So we've got options to you
can limit the charge to 80%, so you're never overtaxing the battery on the charger.
Yes. There's more and more conversations talking about battery health, and there's a lot of conversations about whether or not charging just at 80% will actually help the lifetime of the battery, so the total longevity of the battery by only limiting charge to 80. But you can easily toggle that back, charge to 100% and get your full 8 amp hours out of it.
That's it.
Okay, so most powerful charger, what we think, probably one of the best batteries as well, in conjunction. So you can see when we talked about how we go about getting more power out of a bi-turbo machine, so we're drawing more amps out of a battery. The batteries themselves have more amp hours to compensate for that, but in a conjunction, we've also got really, really fast chargers. So if you are draining your batteries quickly, we've got a fast charger that will charge that high amp hour battery back up again really quickly, so you won't have any interruptions.
There's nothing stopping you from saying, this is a good upgrade to any kit that you've got. So even if you're using system tools with the standard CoolPack batteries, it's an easy upgrade.
Yeah, in fact, we don't just sell batteries on their own, we also sell energy kits, so you'll have different variations of batteries, not just ProCore, but batteries with chargers that you can buy as a complete set.
Yeah.
So if you're buying lots of naked machines, or if you just want to add another battery and charger, or batteries and charger to your set, you can easily just grab one of those box sets off the shelves and you're ready to go. Yeah. Okay, we've gone over a little bit, I think we've done quite well. Rob, you're taking over for a little bit.
I am indeed. I can't wear my headphones at the same time. I'm hearing an echo of myself. Yep, no, I've got a microphone.
Oh, you're mic'd up. Good, good.
Yeah, all good, all prepared.
So, Rob, what have we got left? Any other difficult questions, or have we smashed them?
Plenty of difficult questions coming your way.
Oh, okay. I'm going to have a sip of my cuppa.
Settle in for a long one.
Let's go.
Ballas says, wonderful day to all wonderful tool users. I really hope multi-bay parallel charger is on the way.
I would love to see one. However,
Cable on that.
the cable would have to be considerably large to take that amount of power.
Yeah, chunky.
We often joked about a 3-phase charger. It'd probably
Yes.
be the way it would have to go if you're going to produce a parallel charger like that.
Yeah, think of it this way. Remember, the current, where is it? The current sequential bay, the 6-bay charger, that's an 8 amp hour charge. If you want to be running 8 times 6 amps at the same time, that's a high draw. I don't know if that's something that's even doable, really. It's not something that we've seen on the plans, so we'll say maybe a nice to have, but I don't think we're there yet.
At the end of the day, you're plugging it into a 240-volt socket, so even if the charger was capable of taking that amount of power, probably the wiring in your house probably wouldn't be. So, unless you're planning on running it off of a generator or something like that.
But again, remember, it's a fast charger. It's an 8 amp hour charger. It charges those batteries really quick. Now, we've done some torture testing on it. We were using a leaf blower continuously throughout the entirety of a day. Don't ask why, it was very interesting. And we had a whole bank of batteries on there, and we were quite happy to charge up these batteries easily up to 80% and then replace it, put it back on the machine, and then just go round and keep those batteries on a circuit. They did that really well.
Really, really handy having the visual lights on there to tell you how much it's charged as well. So you're not just blindly waiting for a battery to click. It's done.
Yeah.
It's clear indication.
And it was the big ones. It was the 12 amp hour batteries on the leaf blower as well. So it was just charging those up continuously, and that's the sequential charger. So we think the GAL 18V-6-80 is a pretty good charger, even though it's not parallel.
Along a similar vein from Ballas as well, it says 12-volt multi-charger, maybe, please?
That's plausible.
12 volt for a car, you mean?
Oh, 12 volt for a car.
I was thinking it's multiple 12 volt.
Oh, sorry. Yeah, well, I mean, I think I preempted it because I know people ask for in-car chargers too, cigarette lighter chargers. 12 volt, yeah, that would be nice.
It would be nice, yeah.
I've not heard any plans.
Interestingly, the 6-bay charger was an engineer's solution, not necessarily a marketing solution. And we know from other manufacturers in other sort of walks of life, actually the engineers get it right sometimes. So trust them. So the potential of the success of the 6-bay charger that we currently have for 18 volt, it would make perfect sense to me to do a 12 volt version.
Yeah, let's put some pressure. Put some pressure on us, and we'll pass it up the line and see whether or not something we can do.
If you're working as a crew and you're all using 12 volts, it makes perfect sense.
Yes.
Cool, so we got some more questions from PF Cutters. One of them is, how much heat extraction you have achieved in a percentage from your ProCore bi-turbo batteries compared to your previous version core batteries?
That's a thinker, isn't it?
Yeah, we haven't calculated that. There's a good chance. Well, we could quite easily check that. We could test it on some of our discharge units, and we could put them on, put a thermal camera, and see if we can measure it.
Actually, our discharge units do monitor temperature as well, so
okay.
we can.
There you go. So we could do that.
do that.
If it isn't already information that's gathered from our engineers centrally, maybe we could do a little experiment. As I said, because of all the additional technology inside the ProCore batteries, I'm very confident in saying that it'll be better. How much? Don't know. We can measure it. Yeah, try it for next time, maybe.
Yeah, you'll be surprised at what's contained in that module in those batteries. There's a plethora of information in there.
Lewis Alexander comes up with another comment and says, there is one problem with the GAL 18V160C. Unless it's been fixed with firmware, some ProCore batteries report incorrectly as cool pack batteries. Heard of that before?
That was incredibly early ones, I believe. I think that was down to view it as a Mark 1 module that was in the first ProCores that came out. Obviously, they came out before the 160 actually came out. So yeah, there's a little bit of a lag there. Everything that comes out of the warehousing now, everything that's made works perfectly with it. It's just the slightly older battery with the firmware on that particular module. It works perfectly. It's fine. It's not got the technology in there to read the idea.
If you cut to the close up for us, Rob, and I'll show you two early batteries that we thought we might talk about. We've got the original N-Eraser battery, which was the precursor name for before we had ProCore.
Yep.
This one being a 6.3 amp hour. Strangely enough, running a slightly different cell. This is the 2700.
2700,
Right.
yeah, we went with that first. It was the Betamax
Yes,
of,
that's right.
of cells.
And then obviously we quickly changed the name to the ProCore 18V, and this one is a 7 amp hour. So if you've got one of those kicking about, you've got a real rarity. You might want to hold on to that for Antiques Roadshow.
Yes, don't see them very often.
Not very often. So maybe it's these kinds of batteries you might be putting on the charger and it doesn't read it quite well, or again, maybe some of the really early ProCores just didn't have that firmware. But as Danny says, not a problem. They work just fine.
So,
Okay, let's go, Rob. What else we got?
Next question, are you planning to have a more powerful version of your 12-volt batteries? Not necessarily the total power of Bi-Turbo, but maybe half the power of Bi-Turbo. Like a mini-turbo 12-volt battery.
Just a one turbo, not a bi-turbo.
small one.
Single turbo.
Yeah.
No.
the defining
I don't think so.
factor, unfortunately, about the 12-volt system is the fact that the stick batteries have to fit inside the handle of the machine. Obviously, if we make the cell bigger, we've got to make the handle bigger, else it won't fit.
In theory, it could be done.
could be.
We could just have this stay the same size and all the batteries are in the bottom. So we could have a 21700 base maybe.
Yeah.
But if I'm being honest, it's probably overkill for the 12-volt system.
Yeah.
It would be nice to have. I've not seen anything where we're going to be upgrading the 18650 cells in these batteries to a 21700 equivalent. So I would say not yet, but be interested to see what happens in the future.
To be fair, the individual batteries like this are not stupidly expensive. So, I mean, it's feasible to have, obviously, several different batteries on the go at the same time.
Again, I'm definitely interested to see, because sometimes we get surprised by whatever's happening centrally, and we might get a curveball with a more powerful 12-volt battery. But currently, I don't think so. I don't know if it's necessary either, to be honest. But we'll
again,
see.
there's no such thing as a terrible question, a terrible idea. So we'd like to put these through to the engineering department, especially because they seem to know what they're doing currently.
Yes.
And that sounded terrible.
What a
didn't
dick. Well, we're being nice because, to be honest, we've seen a lot of the products that are coming out. We've shown you some of the products that are coming out, and it's some really good stuff.
Yeah,
so
it is,
they're doing a really good job. Yeah. So, Rob, what else have we got?
There's plenty more. Next technical question from PF Cutters. How are you able to draw double the power with a slight bigger physical size of the 21700 cells than the 18650 cells? Impressive technology.
It is. I mean, credit goes to the cell manufacturers, obviously. We take some credit in our battery construction to compensate for that.
Yep.
But it's just the way they designed it.
Yeah.
It's a bigger cell, so it can handle that kind of load.
When we spoke earlier about the whole, if you liken the cell manufacture to a roller carpet and the anode, the cathode, and the separator in there, it only takes making it slightly bigger in all dimensions for you to be able to double the surface area inside. It's exponential when it comes to a spiral construction like that. So.
But in judging, because everything's bigger, you could argue it's incrementally more robust.
Yes.
So you can pull that, because the limiting factor might be the fact that you might just burn out the battery, the contacts, the channels between the separator, in the separator between the cathode and the anode. If you make everything bigger, then everything's tougher and can handle that draw, that current more. So part of it's because it's bigger, but also you're looking at technology that's evolved since 2001, all the way up to, is it 2018, I think, or 19 we brought out ProCore? I've completely forgotten. But there's been, that's nearly 20 years of R&D and development in battery cells. So come a long way. And one of the early questions we had, I think we were talking about the power stack batteries, which is DeWalt's solution. They're using poly bags, lithium bags. Interesting, but was interesting as in it's kind of like a laptop battery cells. Originally, that was their solution for making compact batteries that was still quite good at high energy draw. When they moved up to their, I think that was a compact battery, relatively low amp hours. When they stepped up to their larger amp hour batteries, they had to make the batteries bigger. So there's a drawback to their system. The poly bag, the bag systems or the power stack batteries, they do handle high load quite well, but I don't think it's necessary because we managed to handle high load again, really high load, on the ProCore battery system, still using the standard cell kinds of batteries.
Remember, we're still talking about physics here, so moving energy from one place to another is producing heat. I'd be interested to know what the heat management system is on that.
Because they're literally stacked upon each other, so I don't know if they're physically in contact. Maybe they can handle the heat better, because we're a slightly different technology, but we've decided that...
I'd say we're quite ignorant on that at the moment. We haven't looked into it, but yeah.
Well, we're not here really to critique our competitors too much. All we can say is that we are very happy with the direction we've taken ours, and we've invested a lot of R&D in making sure that we can do, as we say, double the amps out of our cells
Yeah.
whilst keeping these batteries running perfectly fine.
Next question, what is the version cycle for these ProCore batteries in years? Are there plans to bring out an upgraded future version of these same batteries?
Again, a very good question.
I think cycle limitation, I'm not sure about that myself. That's something I'd definitely have to look into.
The old cells used to be around 1,000 minimum.
Yeah.
I mean, we've still got our standard warranty. Again, remember don't forget to register your batteries and chargers
Yep.
and your tools for extended warranty.
Yep.
So
3 years.
3
Yep.
years. I think typically last time I remember it's at least 1,000. I think that's why we work it out
Yeah.
to be about, originally it was 2 years service on the batteries, now it's 3. It does depend on a number of factors, how well it's been looked after, how well it's been stored.
Yeah.
But I think we typically say around 1,000 cycles.
Yeah.
I think we'll have to check that number, but I'll ask the service guys to confirm that.
But the other point that you had there about future iterations of the 21700 cell, obviously we did a lot of there were a lot of development done over the years to bring the 18650 cell up to a maximum of 3 amp hours. Now that development still remains with the 21700s. However, I would imagine at some point in the future there's going to be developed the ability to make things thinner, widen them tighter, potentially get
Possibly.
maybe 5 amp hours out of a single cell, which will obviously lead to a maximum, if you're talking about a triple stack, of a 15 amp hour battery.
Well,
but that's complete hearsay at the moment.
Well,
I'm just theorising.
Yeah, but even theorising is a good point. But do you need more than 12 amp hours? How many amp hours do you want? Obviously, you want as many as you can, but
There's a few machines out there that we don't currently do it in the cordless that I would say probably would definitely benefit from it if they were to come into to fruition. But benchtop stuff. I mean, it's only going to be for extra runtime
True.
at the end of the day.
Possibly, but at the moment, at least me personally, I've been more than happy with the runtime that we've been getting out of both the 8, definitely the 12. I don't think I've used the tool enough personally to drain it fully, other than maybe some of the max hammers, constant chiseling, that can drain a battery.
I found a 12 once on the table saw, but I was processing material for, hours. It was a long time, yeah.
So we'll see. Maybe, as Danny says, maybe in the future we might add some higher amp hour, but currently our arrangement of 4, 5.5, 8 and 12, I think that's going to do us well for quite some time.
Do we have any plans in the future to expand to tools that utilise multiple 18 volts or potentially a higher voltage, asks Ballas.
In theory, yes. I mean, if you were here when we were talking about our lawn and garden launch, we were doing some theorising on a potential 18 volt lawnmower, and we were theorising that perhaps in order to get the right size of cut, the blade diameter, we might be looking at a twin system. We have already got a twin 18 volt system in our HG lawn and garden DIY range. 2 ProCore batteries on a lawnmower. That sounds good.
It makes perfect sense for a professional range, yeah.
So we'll see. Obviously, the lawn and garden range is evolving. I don't know about normal power tools, but we'll see where the lawn and garden takes us first, the professional lawn and garden range. I don't think anything's off the books at the moment.
No.
Marcus Horn says, another great stream, guys. Thanks.
Oh, thanks, Mark.
Thank you.
Cheers, mate.
He also says, now how about that clothing range?
Yeah, but for some reason, Marcus is very obsessed with getting some, I was going to say some drip. So we are still trying to work out whether or not there's a demand out there for some Bosch Professional Livestream merch. Keep putting pressure on. It's got to be more than Marcus. I don't think Marcus alone is going to be enough to us to get the powers that be to,
well, if he keeps
sign
doing
off
this
on
right, who knows?
Yes, we'll make one bespoke just to you. In fact, I'll sign this and send this one to you, mate. How's that? But we'll see if we can get.
Just insist that he washes it.
We'll see what we can do in regards to just. No, it'd be really nice just to have some Bosch merch, regardless of live stream merch. So we'll see for you, mate.
Yeah.
So we got a couple of questions that aren't quite battery related. I'm just going chronological order at this point because I'm getting confused. Dave's Workbench says, not really battery related, but has the Bosch 8-meter tape measure been discontinued as it is no longer available to buy on the Bosch site?
I think when we did the hand tools one a couple of weeks ago, you were referring to the auto stop function.
Yes.
And I kind of bungled my way through it on the 5-meter tape, which doesn't have it. The 8-metre tape does, and I was handed one just after the live stream. The auto-lock function, I'll just sort of segue into that a little bit for now, is when you pull the tape out, it stays there, and you have a release button to return it back. So it automatically stops. Auto stop makes perfect sense. Other than getting any more for us here in the training centre, I've not had any luck either. But I'd have a word with Lawrence, and I'm sure Lawrence will shine the light on it.
Let's put his feet to the fire and ask him.
Yep.
What's the deal about the 8-metre one? Because you guys are having trouble finding it, so let's find out. Okay.
Stephen Lee asks, are there any new updates on the release date or data on the new multi-oscillating tool?
Oh, if only. So, yes, the new GOP. I think I've teased the fact that it's probably going to be, what was it, the 18V-34 or 36?
36?
36 maybe? Obviously, this product already exists in the Asia market. I think it's the GOP 185 Li.
Yep.
That's probably going to be a very similar product that's going to be brought out in Europe. I'm not sure, but I think there's some form of delay. I think it's just having to go through the usual bureaucratic paperwork to get it signed off.
It's the kite marking, if you will. Obviously, to be able to sold globally, it needs a certain amount of regulations, but to be sold here in the UK, it's slightly different. It has to jump through a few more hoops.
Yeah, really looking forward to having it for obvious reasons, because an update to the multi-tool range is absolutely essential for us, because we've been a little bit slow. And considering we're the ones, with conjunction with Fine, that invented the Starlock system, we've been a little bit slow on the uptake there. So absolutely desperate to get that machine and any other new multi-tools coming out.
We've heard some fantastic things about it as well.
Definitely.
So we're desperate to try that out.
I've tried it.
Yeah.
So I can assure you it's worth waiting for. I think we were hoping that it was going to come out towards the end of this year. Let's see how it goes. At the very worst, then first thing next year, I hope. Okay.
Wolf Lewis believes I'm skipping all his questions. In reality, I'm just getting lost in the chat. One of his questions was, connected multi-bay 18V charger or a connected 12-volt one, guys?
Wow.
Yeah.
Could do. It's not hard. We've got the technology. Maybe if we ever bring out a Generation 2 multi-bay, it might be connected. As the connectivity is becoming more and more common. Out there in the market, you guys are more and more comfortable with the idea. I remember when we first came out with connectivity, everyone went, we don't need this.
No, so I've got to admit, some of the tools, it was a little bit mediocre so far as you could give the tool a name.
Yes.
But as the whole concept has moved forward and evolved, there's a lot more connectivity features on a lot more tools. Well, so it makes perfect sense.
There's a lot of people nowadays still saying, "Oh, I don't need it," and then we show them exactly what it can do, and they're like, "Oh."
It doesn't change the fact that you might not need it, but it's bloody nice to have it.
It's a mod con that everyone just takes for granted on any other application, or any other appliance. Why not a charger? So. We'll see. If we get any inklings there's going to be a Generation 2 multi-bay charger, then we'll absolutely suggest that it's connected.
We'll have to get the engineers fired up again.
Yes, exactly.
Got a quick one from Radine. Not sure we'll have the answer, but will we ever see gallium nitride batteries?
Probably not. I'm not very familiar with it. I might have to do a bit of research to find the pros and cons on that anyway. We are still, as I said previously, the good old lithium-ion, the 18650 and even the 217 is well established. More than enough meets the needs of the current generation of tools. Maybe if we're going bigger and more powerful, perhaps, because there obviously is a limitation to the current ProCore system, we're looking at around 2,000 watts of equivalent quarter performance is the limit for that battery pack, which, as far as I'm concerned, is plenty. But if you want to further down the line replace our 27 kilo breaker, we might have to jump up to some other tech, maybe. But we'll see how it goes. It's early days.
Then we've got a few questions asking about new products, and I think there's so many here that if you're really interested about new products coming out, please ask them in the comments after the live stream, and we'll get back to them afterwards.
Yeah, and don't forget, obviously, when there are new products coming, often we can't give you too much information, but when there is keep your eyes peeled, keep your eyes peeled for the new new tools live streams that come out at least 3 times a year, maybe sometimes an extra one. We had 4 this. We're going to have 4 this year, where we are going to talk about new products. So, and that's when we can really talk about them.
We'll have one of them coming up quite soon, I should imagine.
We snuck in the last one, which was the lawn and garden range, because that was a sneaky peek.
That was a sneaky peek.
But we've got at least got one more live stream talking about products coming out just before the end of the year.
I'm gonna humour Wolf Lewis's question here.
Come on then, what have we got?
Microwave, kettle, coffee maker, and other appliances like Makita.
Right, where do you want me to get started on these, eh?
Ironically, we do make microwaves, coffee makers,
Yeah,
kettles.
Bosch is quite a large company.
Yes.
We've got a whole division that make these things. Now, whether or not we see the point of a battery-powered one, without being mean to our competitors, I'm not 100% sure that the market's big enough for that kind of product, and I don't know whether or not it performs to what people think. Okay, obviously.
He's clarifying that it's 18 volt as well. I don't know if I made that clear. He's looking for cordless.
Oh, wow. Well,
appliances.
cordless, I mean, I think some of those competitor ones are going to be 40 volt or 36 volt, dual battery ones, I think, like, for example, like the microwave. But I'm not going to get too deep into that. Let's talk about what we've got. Microwave, probably not. Kettle, again, probably not. Coffee maker, we make coffee makers. Tassimo is one of ours, isn't it?
Yeah, it is. Yeah.
I would say probably not. And do you know why? Because what we're trying to do is we're trying to focus and concentrate on the core range of 18 volt products, finish that off, and then we can start looking at some of these leisure ranges. Because I'm sure everyone out there, do you want a microwave or do you want a router?
Oh, yes. No, I think...
So we're going to make sure that we get all the 18 volt system tools out first.
We'll put out a poll.
Yes.
And then whatever wins,
they would like
made. That's how it works.
Yeah, they want an 18 volt router with a microwave on top.
You might not like the answer. You might not.
Yeah, so again, let's be serious.
Yeah.
We want to make sure that we bring out the core range of tools, fill out all those gaps, because we've been really aggressive over the last few years, making sure our 18 range is full. And then we'll look at some of these more exotic products later on.
Yeah.
Okay.
Nice. Well, I think the rest of the questions are very much asking about different materials in batteries, which I don't believe either of you have the knowledge to be able to answer.
Let's stay.
He said insultingly.
Exactly. No, we got a lot of knowledge between us, but at the moment, lithium-ion, lithium cobalt technology, that's where we are currently. Anything else is way down the line, and it would be far too preemptive for us to even suggest what other technology we're going to look at. So
we don't know the limitations of those technologies and how we would come up with solutions. Again, that's an engineering question.
Exactly. The ProCore 18 volt battery is a really good range, giving you a lot of power to drive all the machines we currently got, all the way up to the 12-inch sliding miter saw, which is a beast of a machine.
Yeah.
So at the moment, we don't have any tools that need any more power.
No.
So.
Cool. And then the rest are pretty much people asking us to spill all our secrets and tell everyone about what brand new tools are coming. So I'm going to refuse to ask them.
Good.
If they are so desperate. As I said, please put them in the comments of the YouTube video. Doesn't mean you'll get an accurate answer, but you may get an answer. And I think we'll call it there for the questions for the stream.
If we tell you everything, then what are we going to talk about next week, guys?
There'll be no surprises.
No surprises. So we'll keep drip feeding you all the little rumours we get. Make sure we don't get told off for letting off too many trade secrets.
I've been told off already.
Yes.
So
keep an eye on social media, definitely, because obviously that's where all of the initial launch information is going to come from.
You did say
but
did the like and subscribe?
Oh yes, and don't forget to like and subscribe.
There we go. That's what we meant by it. So look at that. Nearly an hour and a half on battery tech. I think that's pretty good. And well done. We've got some excellent questions from the audience. We're really enjoying this back and forth. This is what the live streams are all about. So excited that Lizzie had to leave early. It was too exciting. So Rob had to take over because she was overwhelmed by all the questions. But again, I think it's been a really, really good hour and a half. Really appreciate all the great questions.
Yeah, that's been good.
So I think we're back in 2 weeks. I can't remember what the topic is, so we'll just surprise you closer to the day. Yeah?
Yep.
All right.
Sounds good.
Farewell from me.
Take care and farewell from me.
Bye-bye.
Bye.